Okay, so for target 10 on simplifying using the properties of exponents, I'm just going to pick one thing and deal with it. So I'm going to deal with this exponent of 3 outside the parentheses. So I'm going to get 2 cubed, which is 8. W cubed. C to the 7th cube. Now when I do that, I have a power to a power. So I'm going to multiply those. And then the R cubed. And I'm going to do the same thing over here with this 2. So I'm going to have negative 3 squared. When you take a negative number to an even power, you get a positive. Negative 3 times negative 3. W to the 5th time to the 2nd. So power to a power, I multiply those. C cubed to the 2nd. I multiply those. R to the 0 to the 2nd. I multiply those. I still get R to the 0. And remember, anything to the power of 0 is 1. So I suppose I could put a times 1 in here, but I don't need to. So then I'm just going to multiply the like parts. I have some integers here. 8 times 9 is 72. Remember, I'm just multiplying these. That's what this means, multiplication. I'm taking w cubed times w to the 10th. And the rule with those, when you're multiplying powers with the same base, you add the exponents. Same idea with the c to the 21st and c to the 6th. You get c to the 27th and the r cubed. So there's your final answer for number 1. For number 2, I'm going to do basically the same type of thing. So I'm going to start with the numerator and deal with this 2. So I'm going to get 2 squared, y squared, and z squared squared. So I multiply the 2 and the 2 with the z. Doing the same thing in the bottom, I'm going to get 5 to the 5th power. And I don't know what 5 to the 5th power is off the top of my head. So what I would do is I would go to a calculator and I would type in 5 to the power of 5. Or 5 times 5, which is 25. Times 5, which is 125. Times 5, which is... Whoops. 625 times 5 a 5th time is 3,125. And then I'd have y squared to the 5th power. And again, power to a power, I would multiply those. And z is the 5th power. And then I would reduce this fraction if it can be reduced, but it can't. 4 and 2 do not go into 3,125. So I'm just going to leave it. I deal with my y's. Y to the 2nd over y to the 10th. I subtract those. So I get y to the negative 8. But you can't leave a negative exponent, so you make it y to the positive 8 in the bottom. Or in other words, the 2 y's on the top cancel 2 of the 10 y's on the bottom, leaving 8 y's on the bottom. And the same idea with the z. Z to the 4th divided by z to the 5th is z to the negative 1st, or just a plain old z to the 1st in the bottom. So there's your final answer for number 2. Okay, getting a little more difficult. Third one here. And again, going to just kind of take it in the same steps. So dealing with this numerator, negative 5 squared is 25. T to the 4th squared is t to the 8th. R cubed squared is r to the 6th. On the bottom, negative 5 to the 3rd power is negative 125. T squared cubed is t to the 6th, and r cubed. So then I'm going to reduce this fraction. I can divide them both by 25. 25 divided 25 is 1. Negative 125 divided 25 is 3, negative 3. So you're going to have negative 1/3. Dealing with the t's, I subtract 8 minus 6 is t squared. And that's a positive, so it stays in the numerator. And r to the 6th over r cubed is r cubed when I subtract those. So basically, your answer is negative t squared r cubed over 3. The fourth one is an application using scientific notation where we would often use some properties of exponents. So here we have a rate, how many meters per second a radio signal travels. And this question is wondering how many seconds will it take for a radio signal to travel from a satellite to the surface of the Earth if the satellite is orbiting at a height of 1.02 times 10 to the 8 meters. So we could use this formula, distance equals rate times time. But this question is asking how many seconds, so it's asking for a time. So if I solve that equation for t by dividing both sides by r, I get time is calculated by distance divided by rate. So I want to take the distance, 1.02 times 10 to the 8th, that this satellite is above the surface of the Earth, divided by the rate, which is 3 times 10 to the 8th. And the units here, this is meters, and this is meters per second. So what happens is the meter units cancel, and you have basically a divide seconds in the denominator, so our units end up being how many seconds it is. And then what you can do is you can just divide out those numbers. 1.02. Uh-oh. I'll grab my calculator. 1.02 divided by 3. So I get 0.34. So I'm basically just trying to simplify this. So when I divided this, I get 0.34. And 10 to the 8th over 10 to the 8th cancel. It's 10 to the 0 power. So that's how many seconds it is. I guess if you wanted to report it in scientific notation, it would be 3.4 times 10 to the negative 1 seconds. But normally we would do that. The last one would be kind of the exceeds type level. And again, there's lots of different orders that you could do this. I'm going to work on the inside first. So I'm going to deal with this 4. Negative 3 to the 4th power is a positive 81. Remember, a negative number to an even power is positive. G to the 4th is G to the 16th. H to the 6th to the 4th is H to the 23rd. And I'm going to deal with this one. So I have G cubed, which is G to the 9th. H squared cubed, which is H to the 6th. So I'm using that property where I have a power to a power, and I'm multiplying those. Now maybe I'm getting kind of confident in my abilities, so I'm going to try to combine steps. I could do that in the bottom here. So I'm going to have a G cubed squared, which is G to the power of 6, but then I have another G squared here. So I take that G to the power of 6 from the right side and add the G squared, or multiply the G squared, but I add the exponents. So I get G to the 8th. So this would be G to the 6th. I'd have a G squared here. Total, that's G to the 8th. Doing the same thing with the H. I have an H squared here, and I have an H to the 1st here, so there's going to be an H cubed, 2 plus 1. And the 3 just stays in there. So now I'm going to, after I do some simplifying, now this is all still to the negative 2nd power. So I'm going to reduce this. 81 divided by 3 is 27. G to the 16 over G to the 8th is G to the 8th. We subtract the 16 minus 8. Subtract the 24 minus the 3. I get H to the 21st. And then I still have the G to the 9th and the G to the 6th. So I'm going to add those. G to the 9th times G to the 8th is G to the 17th. And I had h to the 21st times h to the 6 is going to be h to the 27. And then finally, I'm going to apply this -2. So I'm going to make it +2, and everything's going to go on the bottom and get a power of 2. So it's going to be 27 squared g to the 34th and h to the 54th. And you could simplify whatever 27 squared is. I don't have that right in front of me. I probably have it in the next slide. And then that's all under 1. No, I don't have it. So 27 squared would be 729. So we have 1 over 729, g to the 34th, h to the 54th. Any questions? Yes, Ellie.